So, into the next thing, we're going to have a panel discussion. Yeah. So we might invite Chow, Sampras, Amir, myself, and Ethan's going to host a little panel discussion, and we've also got another quiz to do.
Hand up. We'll do it through the mic, if that's okay.
Are there any questions? Otherwise, we could go directly to the quiz. I can't see, it's so bright up here.
Hello, everyone. Just a quick question. Are we reducing the number of volumes as well as we decrease the TR?
Sorry, can you say that again?
Are you reducing the number of volumes acquired as well when we reduce the TR?
No, so essentially you can make your number of volumes to equate to the length of your paradigm. So that has no effect on your TR. It may affect the reconstruction speed of it, like it depends on your vendor and your scanner efficiency, but you can put as many volumes in as you like.
Thank you very much.
Have you been able to use any sort of AI reconstructions or AI distortion correction methods to try and speed up anything? Is that something that could be useful?
So currently, the distortion correction is not real time. So that's because it takes much longer to implement. So it's a good idea, AI-based distortion correction, but I guess the problem arises with training, and you need training data, and then according to my knowledge, it's not been implemented for fMRI neurofeedback yet, but definitely a promising avenue.
I think our GE scanner has a nice AI distortion correction for that.
Okay.
It seems instantaneous to us, but we haven't actually looked into exactly how long it takes. It could be still too slow.
Yeah, that would be interesting then too. Do you have any neurofeedback experiments running on your...
No, we haven't done anything in live time yet.
Yeah.
Yeah, and I guess that's one of those points. I didn't emphasise it in the talk, but you can always switch which is doing the correction. So if you're distortion correcting on your scanner, it takes a little bit longer to reconstruct. That's potentially okay because you can remove other corrections that you might need to remove. You can remove from the turbo brain or the system that you're using accordingly. And that's part of understanding your scanner and your paradigm and what where you want to position your ROI.
And as Beck mentioned, so the distortion correction that we do is for the structural MRI. But for the functional MRI, so you're talking about functional MRI? Functional MRI, yeah. So that one, if you had an AI-based one, that would be helpful.
Yeah.
Hello. I had two questions actually. So the first one, I'm not sure if it's maybe a stupid question, but why can we not use multi-echo for neurofeedback? Then also for denoising, or is that just something that hasn't been tried but could be done?
I guess it's essentially part of what you want from your neurofeedback. So that's going to increase your acquisition time. It's going to increase your reconstruction time. If you are providing your feedback at the end of a block, maybe that's not so much a problem. But if you were trying to provide it at the end of every acquisition or every TR, then you are lengthening your feedback window. So yeah, definitely what I presented today are all things to consider. It doesn't mean you can't do them, but they're definitely part. There's many keys to the cog of. Is that the right saying? Yeah, of setting it all up.
Yeah, okay, no, that makes sense. It would probably be a bit more accurate, but it would just take longer, and we kind of want to have very short feedback. And then
you'd also need your reconstructor to be able to combine the data and then send it over, which is probably something you need to add into the ICE pipeline or something, or use some kind of open recon situation. Yeah.
And then a thought I had was, because it's really nice to look at one region of interest, but like I feel like it would be super interesting also looking at functional connectivity, like DCM stuff or something. Is there anything like that's in the literature or you thought about, or I don't know?
Yeah, so DCM has been looked at when the feedback is intermittent. So let's say you've got 30 or 40 seconds of data before you provide your feedback. So DCMs can be run on that 30, 40 seconds of data. And similarly, functional connectivity, you can simply do a Pearson's correlation between two regions. You can feed that back. So that has been done. But when you talk about feedback after every volume, then you probably can't do DCM, but you can still do, there's a measure of FC that some studies have used where you kind of compare the two regions' direction of activity and compare it with another control region. So if the two regions have the same direction of activity, you give them a binary plus feedback. So it's a binary feedback of 1 or 0. And if the two regions are down and the control regions are on the other side, then you give like a 0. So it's 1 or 0. That's pretty much where they are at with respect to just one volume-based FC. But yeah.
Okay. Okay, thank you.
Okay. If there's no other questions, maybe we'll move on to the quiz. We're just going to do a short quiz to make sure you've all been listening, and then we might just have a 5-minute break if anyone needs to grab a drink or something, because I'm aware that there's people that have been in the room the whole time, which is amazing. All right, sorry. Oh my gosh.
Back just while you set up, just follow that question about function connectivity. So the TPV actually can have a function to run the TPV has a function to detecting the function connectivity. If you're interested, I think Amir's bring the laptop of TPV. So if you're interested, you're welcome to have a look. So there's a functions for detecting the function connectivity as the feedback. So we have the laptops in here. Yeah, if you're interested.
So same again, I'm not sure if everyone was in here last time, but you can either scan the QR code or you can go to menti.com and pop in that code. Do you want to stay with me? I don't know. Okay, so in this case, it's best to do it in the real time. I can see people changing their answers. I saw that. Well, you want to do some kind of motion correction, yeah. Oh, someone said none, yeah. Yeah, I mean, you can think if you're thinking about it in terms of delays, yeah, it is slowing things down. But if you've got a particularly small ROI and you need it to be accurate, you need to correct for your motion. Yep, so we could say all of the above because all of these can potentially cause delays. They can increase your file size, they can shorten your TR, cause artifacts, that sort of thing, so all of the above.
Perfect, yeah. So onset and offset of each block for each condition is the right answer for the PRT file.
So, Amir, lots of people, or a few people put 4. Why is that not the right answer? I mean, sorry, percentage change. Why is that not the right answer?
You'll find it out probably in the next question.
Oh, okay.
Yeah, so person signal change goes to your RTP file, which is the output of TurboBrain Voyager. But that PRT file, which I know the naming is a bit tricky, was only the onset and offset of the conditions.
I wasn't sure if there was something wrong with the system or everyone's thinking about it. Feel free to have a guess so it can guide us on the answer. What do you want to?
Yeah. Yeah, so perfect. This was the difference. Like what you see in TurboBrain Voyager is just the activation of the target region. And what we actually show to the participant, which is the difference of that thermometer in the neurofeedback task, is that it both has been deconfounded. So the effect of noise from that confound region has been regressed out, and it's kind of a weighted feedback, so it's kind of normalized. So the correct answer is 1.
Oh yeah, this is multiple options. Yeah.
Sampras says correct.
People hear so many keywords of TBV, so the correct answer is basically TBV front engine FNE, and could be potentially FSL or SPM if you like to explore. Unfortunately, I didn't put it into the multiple choice. So yeah, sorry about that. Yeah. So the correct answer is actually everything. Yeah. Probably the same problem for this one. Oh yeah, this one.
I think people didn't pick the other ones.
It's another question that's showing you have your own choice to vary the options that you use to program the task and in the front end. So the correct answer is everything, the one you feel comfortable.
Oops, we're missing an
So the correct answer is the 1 TR or several TR. So sometimes it depends on your experiment design. Sometimes if you want to continuous feedback, so you give the feedback for every TR, the person get feedback continuously. But sometimes it is, if the block design, so you wait for a certain TR and give an average feedback. So the last one is after the whole function MRI, so that's just our typical way to analyze the function MRI data. So we really want the feedback to generate during the scan.
And that's it. All right. So we might just take a 5-minute break if anyone needs a break to grab a drink or anything.